Anyone know?
Shakespeare's play Julius Caesar.
Julius Caesar. You guys read Caesar anymore?
Yeah.
Yeah? Do you remember what it means to beware the Ides of March? You don't remember?
I don't know.
Yeah, he had like a psychic, they called it, I think, a soothsayer working for him. And Caesar was so cocky. And this guy was like, you need to beware the Ides of March. The Ides of the month are like the middle day of the month. So like March 15th. So the Ides of March are March 15th. And he kept saying, you need to be careful on this day. And that was the day that the Senate, all of his friends and stuff, stabbed him in the back and murdered him.
Oh, like literally? Like not like
Literally.
direction, like they actually did.
His friend Brutus, his best friend Brutus was a part of it. And he stabbed him in the back, and Caesar turned around and said, "Et tu, Brute?" Like, and you, Brutus? Like, he stabbed him in the back. And that's where the expression comes from. Yeah. You're learning more about English today than math. All right. I always liked a little Bill Shakespeare. Heck of a guy. Okay, so today, here's what's going to happen. I'm going to call on you guys to give me the info. All right, you're going to have to give me the info to this stuff. So back in the day, I've been teaching this class for 9 or 10 years now. And up until last year, I always let students use their calculators to get a lot of values to plot to graph these things. And then last year, Mr. Shelton came up to me because he was teaching this class at the time, and he said, "What if we do these without calculators?" And I said, I like it. So we are going to graph all 5 of these without a calculator. And at first, from a student's perspective, you hear that and it sounds a little scary because you want that calculator as like a security blanket, which I get. But I feel like in doing so, it really strengthened the understanding and the concept of graphing these things. I think it was for the better for the students, not to make your life more miserable, but I think it helped make things make more sense. That's what I think. We'll see. So we are going to gather all of this info, and then we're going to talk about how we sketch this on the coordinate plane. We're going to do rough sketches of these rational functions. Let's begin. So, Mr. Click, I'm going to call on you first. And because I'm calling on you first, I'm going to let you pick any one of these 5 things and tell me what it is. Name the line. X equals 2. This happened over and over and over again yesterday. I would say, give me info, and that's exactly what everyone said. 2. And as soon as you guys on a quiz or a test write just numbers and not equations, minus a half, minus a half, minus a half, minus a half. Make sure you guys are naming the equation. So the vertical asymptote is x equals 2 because that's what makes the bottom 0. So the way we go on the coordinate plane, we are actually going to dot our asymptotes on the coordinate plane. So on the coordinate plane at x equals 2, I'm going to draw a dotted line to represent that vertical asymptote. Pretty little dotted line. Okay. Mr. Davis, there are 4 other things that I want. I'm going to let you pick any one of them and tell me. Why? It would be. Yeah. So for the horizontal asymptote, we're comparing the degree between the top and bottom. Yesterday in both classes, block 2 and block 4, the people I called on said they thought the horizontal asymptote was y equals 3 in both classes. Well, I fully get it. But we're looking at the degree. On bottom, there's like x to the first. On top, there is no x. In other words, you could think of it as x to the 0. The bottom degree is bigger than the top. So the horizontal asymptote is the x-axis. You can write x-axis or y equals 0. They are one and the same. They are synonyms to each other. I don't care how you guys write it. So we are going to draw our horizontal asymptote on the x-axis. We're going to draw that dotted line. Okay, so here's what I told the class yesterday. As far as understanding what these graphs will do of rational functions, I want you guys to understand this. This is like big idea concept of the day, okay? Here's what I know. If I have a vertical asymptote at x equals 2, and a horizontal asymptote on the x-axis. Here's what I know. On the right of that vertical asymptote, okay? So over on this side of 2, over here, I know the graph is either going to look like this, so it's going to kind of hug that vertical asymptote and then bend and then approach that horizontal asymptote. The graph is either going to look like that, or it's going to be down here and look like this. It's going to do one or the other. It's our job to figure out, is it up in this region or is it down in this region? I'll talk about how we figure that out, but I want you guys to understand what these graphs are going to do and what they're going to look like. It's either going to be up here or down here. Same thing on the left of that vertical asymptote. To the left of the vertical asymptote, the graph is either going to be up here and like snuggle to those asymptotes like this. It's either going to be up there or it's going to be down here. It's our job to figure out, is it above or below that horizontal asymptote? My question is, first of all, why can't it be both? Why can't, like, over on this side, why can't both of these things happen? Curious if anyone knows that. Okay, these things are, yeah.
Is it because that I was like graphing them a lot, I accidentally did today's homework instead of yesterday's homework, and I was looking at it. It looks like it's always going to be opposite of each other. Like if one is in the bot, like they're always going to be opposite. Like the one on the left is always going to be opposite to the one on the right. And
They don't have to be. I'll talk
they don't
about
have
that.
to be, but
I'll talk about that. But my question was, why can't both of these things happen? And the reason is these things that we're graphing, guys, they are functions, meaning they have to pass the vertical line test. They have to. So you can't have like these, both of these can't be here because then it wouldn't pass the vertical line test. Only one or the other will be there. Okay. So Nathan's talking about, you know, he noticed that a lot of these, they're opposite of each other. Like a lot of them, they look like this, where they're diagonal. They don't have to be, you know, they can look like that, where they're both up there kind of forming a volcano. But again, it's just our job to figure out in what region are these things. And that's what the other info is going to tell us. Okay. So the next thing I want to find is the x-intercept. Now I'm going to talk about this one. So in math, in general, this has nothing to do with this particular topic. This has just in math. If you want to find intercepts, you plug 0 in for the opposite letter and then solve for the letter you're trying to find. That's any equation in the world. That's not just this. So if I want to find the x-intercept, I'm going to plug 0 in for y and then get x by itself. Okay, so I'm going to do that. I'm going to work that out. So if I want to find the x-intercept, I'm going to put 0 right here for y. Remember, g of x just means y. So I'm going to put 0 in for y. And I want to get x by itself. So that 0 equals 3 over x minus 2. And if I want to get x by itself, well, first thing I want to do is get rid of that fraction. So I'm going to multiply both sides by x minus 2. So on the right side, the x minus 2's will cancel. It's like the whole point. And on the left side, 0 times x minus 2 is just 0. 0 times anything is 0. So I'm left with 0 equals 3. What does that tell you about the x-intercepts? If you get 0 equals 3. No solution. In other words, there is no x-intercept. That means this graph that we're about to draw will never cross the x-axis ever. So none. Another way, you guys for x-intercepts are not always going to have to set these things equal to 0 and solve. I made a comment on the homework. I said zeros are what make the top of your fraction 0. Whatever makes the top of your fraction 0, those are your x-intercepts. So since there is no x up here on top, nothing will ever make this 3 become 0. If there's nothing I can plug in for x, that'll make the top of that fraction equal 0. So that's just another way to think through why there's no x-intercept. The y-intercept, we do the same thing. The y-intercept, we're going to plug 0 in for all the x's to get the y-intercept. So if I want the y-intercept, I'm going to put 0 in for x in the original equation. And I'm just doing some mental math. If I put 0 right here for x, I would get 3 divided by 0 minus 2. So 3 over negative 2. So negative 3/2. Negative 1.5 is the y-intercept. That gives us a whole lot of information because I'm going to plot the y-intercept on the coordinate plane. I'm going to put a point at 0, negative 1.5. The reason that gives us a lot of information, I knew on the left of the vertical asymptote over here, the graph was either going to be up here. We guys look at this. The graph was either going to be up here or it was going to be down here. It was our job to figure out in which region is this thing. By finding that point, I just discovered to the left of that vertical asymptote, the graph is down here in this region because it has to go through that point. So I'm just going to draw a rough sketch. I'm going to just have it approach those asymptotes. I'm not going to be very picky on your guys' graphs. What I will be picky about is just that it's getting closer to the asymptote so you understand that concept and that you're not crossing it. Kid yesterday said, Mr. G, what if I just kind of accidentally go through that vertical asymptote? And I said, then you are wrong. So I'm not going to be very picky, but those are things I'm looking for. So the only thing I don't know, oh, we didn't talk about the holes. Are there any holes in this problem? Marwan, why are there no holes? Yeah, nothing canceled. Holes occur when factors cancel out, when you can cross things out. Nothing crossed out, nothing factored. So there are no holes in this problem. The only thing I don't know is to the right of that vertical asymptote. Over here, I still don't know if the graph is up here or down here. It could still be either one. This is what that little table is off to the side for. I want to figure out to the right of that vertical asymptote over here. So for values bigger than 2, where is that graph? So all I do, I just pick any number bigger than 2 to plug in for x. What's a number bigger than 2? 3. Let's plug 3 in for x, okay, to see what's going on the right side of x equals 2. So if I plug 3 in for x, again, we're just going to do some mental math. 3 divided by 3 minus 2, so 3 over 1 is 3. So I'm going to plot that point at 3, 3. So I knew the graph was either going to be up here or down here, and I just figured out it's up here. And there's our graph. Hello, rational function. And sometimes you don't even need to put in anything over here. Like if let's say we had enough info from our intercepts to know like what was going on both sides, we wouldn't even need the table. The table is only needed if you don't know what's going on either side of the vertical asymptote. We just need to pick values on either side. What I would do before last year, I would do all the same stuff, but then we would pick a bunch of points to the right of 2 and left of 2 and make a whole big table of values and plot a whole bunch of points. It was very tedious. And I think it got in the way of like understanding what these graphs look like. Whereas this is not as tedious and more understanding. All right, number 2. So we're doing 5 today, and each one just has like a little bit of a different wrinkle. Number 2, Mr. Middleton, since you are the first one, you get to pick any one of these 5 things to find for me. Any one of these 5. It is. The x-intercept is 1/2. So the very first thing, if you want to find your x-intercept, you guys have 2 ways of finding the x-intercept. You could either plug 0 in for y and then solve your equation for x, or just know your x-intercept is always whatever makes the top of your fraction equal 0. And if you can't look at the top and think through what makes it equal 0, then by golly, set it equal to 0 and find out. Your x-intercepts are always what make the top equal 0. Add 1, divide by 2. So 1/2 comma 0. I'm going to plot that point. Very good. Mr. Pena, you got 4 other things to choose from. Pick one and tell me what it is. The vertical asymptote is x equals 0. Very good. Don't just say 0, but x equals 0. The vertical asymptote is whatever makes the bottom equal 0. So 0 does. So x equals 0, otherwise known as the y-axis. X equals 0 is the y-axis. So we're going to dot that vertical asymptote. Hello, vertical asymptote. Jersey, you got 3 things to choose from. So look at the degrees. Notice that on top and bottom, the degrees are the same. Okay. When they're the same, your horizontal asymptote is the fraction that's out in front of those x's. Name the line. Y equals 2. Yep. Notice on the top one, the very first one, the bottom degree was 1 and there was nothing on top. There are no x's on top. When that happens, it's always the x-axis. When they're the same, it's y equals whatever your fraction is out in front. Okay. So y equals 2. So I'm going to dot that line. There we go. We got 2 more things to find. 2 more things. Jace, do you want to find the y-intercept or the holes? The y-intercept is none. How do you know that? Yep. Very good. So for 2 different reasons, there's no y-intercept. For 2 different reasons. Number 1, if we plug 0 in for all the x's, like Jay said, we would have -1 divided by 0, which is undefined. You can't divide by 0. That means there is no y-intercept. None. But how did we know there wasn't going to be a y-intercept anyway? Just from the graph. Emma? Yeah, the vertical asymptote is on the y-axis. Your graphs will never, ever, ever touch or cross vertical asymptotes. Your graph cannot exist at those vertical asymptotes. So if your vertical asymptote is on the y-axis, it's impossible for your graph to touch the y-axis, which means it's impossible to have a y-intercept. Just trying to make some connections between all this stuff. What about the holes? Miss Odell, are there any holes?
No.
How do you know? Yep, nothing canceled out. So now, here's what I know. Similar to the top problem, to the right of the y-axis, to the right of that vertical asymptote, the graph is either going to be up in this region, up here, or down here. And because I have a point down here in this region, I know where that branch is going to be. It's going to be down in that bottom right region. So it's going to snuggle up to those asymptotes as best I can. La-di-dee, la-di-da. There we go. The only thing I don't know is what's going on left of the y-axis, to the left side of that vertical asymptote. This is where we use the table. I'm going to pick any number left of the y-axis. Any number will work. You use -1, -2, doesn't matter. But I need to pick a number less than 0 on over here. So I'm going to plug -1 in. So if I plug in -1, let's do some mental math. I'm going to plug -1 in for these x's. So -3 on top, -1 on bottom, so +3. So there's a point at -1, +3. Right there. And I knew the branch, the graph was either going to be up here or down here. And because that point is up here, I know that's where the branch will be. You guys think of these? Having a blast? You love them yet? Well, that's good. A lot of people struggle with the horizontal asymptote rules. That's typically the most missed thing, is comparing the degrees and knowing those rules. All right. 3. Time we got? We good on time? Oh yeah, we're good on time. 3. Okay. So something happens on this one that didn't happen on the previous 2. I didn't make a comment on the first 2 because it didn't happen, but honestly, we should go into all these problems looking to factor and cancel if possible. On the first 2, nothing factored, so I didn't even really think about it. But here, I look to see, does the bottom factor? And sure as shooting it does, because I can find 2 numbers that multiply to -2 and add up to -1. So this would be x minus 2, x plus 1. Nothing canceled, which that's okay. It's actually to your benefit if nothing cancels out, because that means there's no holes. Nothing cancels out, so no holes. All right. Miss Newcomer, there are 4 things to choose from. You get to pick any.
The horizontal asymptote is
Name the line. Y equals 0. How'd you know? It is.
because the degree at the bottom is
Yep. So the bottom degree, x squared, is bigger than the top degree. So it's always the x-axis when that happens. So we're going to dot the x-axis. Alrighty. It's Ratcliffe. 3 things to find. Yep, there are 2 vertical asymptotes. In the video last time, I paused it and I said, very importantly, he just made a comment. You guys can have multiple vertical asymptotes. However many factors you have on bottom with x in it, that's how many vertical asymptotes you're going to have. You can have multiple. You can only ever have at most 1 horizontal asymptote, at most. But we can have multiple vertical asymptotes. So x equals 2 and x equals -1. So I'm going to dot both of them. I love graphing. Yes, I do. I love graphing. How about you? Oh, I thought everyone would repeat it. I really did. For a split second, I was like, maybe. Okay. I got to find the intercepts. But I want to explain something first where there's multiple vertical asymptotes, okay? So on the previous 2, I said on either side of the vertical asymptote, you're going to have branches. We need to figure out where they are. Someone yesterday asked an awesome question. She said, well, how do you know that the graph is going to be on both sides of the vertical asymptote? Like, how do you know that? And I said, because when we talk about domain, we're talking about things we're allowed to plug in for x. Like on this very first example, the only thing we weren't allowed to plug in for x is 2. That means the graph is going to exist at every other x value in the entire world except 2. It has to. I'm allowed to plug in anything else. That's how I know. The graph's only not going to exist at the vertical asymptotes. What that means for this one is this. To the right of 2, the same thing is going to happen as on the previous 2. To the right of this most right vertical asymptote, the graph is either going to be up here or down here. Nothing changes. And to the left of this vertical asymptote, the graph's either going to be up here or down here. Nothing changes. What changes on this one, and I'm not really going to hold you guys too accountable to knowing what I'm about to talk about, because without a calculator, this part gets pretty tough. So I'm not going to really push you guys on this. But the graph is going to exist between these vertical asymptotes also. It's not like it just won't be there. It will be there. And there's really 3 things that could happen. It could either like form kind of like a parabola inside of here, where it like snuggles up to these vertical asymptotes going up in both directions. It could be down here and do that same thing. actually what happens on this one is it snuggles up to this left vertical asymptote. It crosses the x-axis, like snakes through the x-axis, and then hugs the right side of that vertical asymptote. We'll talk about that. But again, I'm not going to really like hold you guys too accountable to that. But that's what's going to happen on this problem. We need to find the intercepts. The x-intercept, guys, is whatever makes the top of your fraction equal 0. You don't have to set it equal to 0 and solve and go through all the motions. It's whatever makes the top 0. 0 makes the top 0. So the x-intercept is 0, 0, or the origin. The y-intercept is whatever you get when you plug 0 in for all the x's. This is the fun part. I don't know why. Finding the y-intercept to me is like satisfying. I don't know why. Because like it's just all the x's go away. So you would have 0 divided by -2. While you can't divide by 0, you can have 0 on top of a fraction. This just equals 0. So the y-intercept is also 0, which we already found. Which kind of stinks because we need to use our table on this one. We don't know a lot about what's going on either side of our asymptotes, like to the far right and far left. So we need to make a little table. To the right of 2, over here, to the right of 2, I need to figure out, is the graph up here or down here? Which means I just need to plug in a number bigger than 2 for x. So I'm going to plug in 3. We just have to do some mental math. I'm going to plug 3 in for all my x's and get the y value. So I would have 3 divided by, and then it would be 3 squared, so 9, minus 3 is 6, minus 2 is 4. So 3/4. 3/4. That means there's a point on this graph at 3, 0.75. 1, 2, 3, right up here. So I knew the branch was either going to be up in this region or down here, and I know it's up here because of where that point is. We're going to do the same thing to the far left of the -1. So I want to figure out what's going on left of x equals -1. So I'm going to plug in -2. And do some mental math. So I'm going to have -2 on top. On bottom, I'm going to have -2 squared. So 4 minus -2. Watch out for your negatives. So I would have 4 minus -2. So 4 plus 2 is 6. Minus 2 is 4. So -1/2. Did I do that right? Is that right? Okay. So I'm going to plot a point at -2, -1/2. So down here. So I know the graph is going to be down here. In between those vertical asymptotes is not too much of what I'm going to be concerned about. So I'm just going to show you guys what this looks like in between. So what happens on this one, it goes up towards that left vertical asymptote. It snakes through the origin, like a little snaky snake, and then kind of goes down to the right of that right vertical asymptote. This is what happens in between those. The reason I wanted to show this one mainly is to remind you guys that graphs can never, ever touch or cross vertical asymptotes. That will never happen. It is impossible. Graphs can touch or cross horizontal asymptotes, like in the middle of the graph. Horizontal asymptotes are all about what is the graph approaching as x gets really big in positive or negative direction. It's not about what's happening in the middle. So here's an example of that. Our horizontal asymptote is the x-axis, and our graph is crossing the x-axis. That's allowed. We got 2 left. You ready?
Yeah.
You ready?
Yeah.
Okay.
Wait, so it can only cross in the right.
Like not at the origin, but just like in the middle, not at as x is like really big or small. Like you could cross at 1 or 2 or 3, like somewhere in the middle of the graph. Yeah. All right. What have we not had to deal with yet? Poles. Huh. Here we go. So I go into this one. And I'm gonna look to factor and cancel right off the bat. So the top is x plus 3x minus 3. Hopefully we're good with difference of squares. And the bottom, oh, what's that noise? X minus 3x plus 1? Yes. The x minus 3's cancel. So for the first time, we have factors that cancel out. Okay. We have factors that cancel. So what I know is this. Since x minus 3 canceled out, that's where a hole gets created. There's a hole when x equals 3. When you guys write the hole, though, you're not going to write x equals 3. You're writing an ordered pair. You're writing a point on the graph that's missing. So I'm going to write 3, comma, and then I have to find the y coordinate of the hole. How do we find the y coordinate of the hole? Plug 3 in for x, but not in the original equation, because that'll give you undefined. Plug 3 in for x in the simplified fraction, the very last fraction after you factor and cancel. So I'm going to plug 3 in for these x's right over here. So I would get 6 on top, 4 on bottom. So 3/2 or 1.5. And the way we represent that on the coordinate plane, we're actually going to draw a hole. We're going to draw a little open circle on the graph. At 3, 1.5, we draw an open circle. Our graph will go through that open circle. That's important to understand. Your graph goes through the hole. It just doesn't exist where that hole is. Yeah.
So if it was if the vertical asymptote went over there, could the line
No. So that's a really good question. This is rare, but it could come up. So before I talk about what you just said, so on this problem, there's a hole at x equals 3. There's a vertical asymptote at x equals -1. Okay. So I'm gonna start there, but then I'm gonna address your question. Okay, so there's a hole at when the factors cancel. There's vertical asymptotes at whatever makes the bottom 0 of the thing that didn't cancel. So your question is, what if you have like a hole and a vertical asymptote at the same place? Is that your question?
Yeah.
So I will answer the short version is that's impossible. Okay. So a hole and a vertical asymptote are never going to happen at the same place. This is rare, but since the question came up, like let's say you're doing a problem and you have something like this. Let's say this happens where you factor and this happens. And so like the x plus 2's cancel. So your first thought would be like, oh, there's a hole when x is -2. But then you're like, but wait, there's a vertical asymptote when x equals -2, right? It looks like they're at the same place. A vertical asymptote trumps a hole. So like if it looks like they're at the same place, that just means there's a vertical asymptote there. There's not a hole there. That means there would be no hole. Yeah.
Come on.
I don't know. I mean, it's possible. I'm not like trying to trick you, but I'm also, I don't know. I'd have to look at stuff. Possible. Es posible. All right. Let's find the rest of this stuff. Jersey, what's the horizontal asymptote? It's one or the other.
One,
Why?
because there's this hole in front of the x's,
And so why are we looking at the numbers in front of the x's?
because they're the same.
Yeah, exactly. Yeah, the degrees are the same. X squared and x squared, which means it's going to be y equals the fraction that's out in front. So y equals 1. Very good. That's not so scary, right?
No.
So I'm going to do my dotted line on that horizontal asymptote. at y equals 1. And those are our only asymptotes. Let's find the intercepts. So for the x-intercept, I've made a comment, and I haven't been trying to mislead you, but I also want to make sure that I address this. I've said for x-intercepts, just look at what makes the top of your fraction equal 0. Like I made that comment several different times. That's true, but it's what makes the top of your simplified fraction equal 0. I get a lot of students that will say there's x-intercepts at -3 and 3, because both those make the top 0. Well, there's a hole when x is 3. You're never going to have an x-intercept and a hole at the same place. Like those things won't coincide. So x-intercepts are whatever make the top of your simplified fraction equal 0. So there's an x-intercept at -3. Anybody know what the y-intercept is? It's the y-intercept.
The y-intercept is 0, 3.
0, 3. The y-intercept is whatever you get when you plug 0 in for all the x's. So if I plug 0 in for all these x's, all I'm left with is -9 over -3. Like that's all that's left. All the x's go away. So the y-intercept is +3. Dodgy, you made a comment about that table. I said the table is only needed if we don't get enough info from our intercepts. We don't need the table on this problem. Because to the right of that vertical asymptote, we have points. So we know the graph will be up here. When you go through the hole, don't like blow past it, because then you're kind of contradicting yourself. Approach the hole, stop, and then come out the other side like this. If you draw through it, then you're basically saying the graph is there, but it's not there. So just kind of get to the edge of it and then go to the other side. And on the left of the vertical asymptote, we have a point. So we know the graph is down here. We don't need that table. Get out of here, table. We don't need you. With your grubby little hands. There it is. Un mas. Yeah.
So when you find the hole and you find it like in that right,
Mhm.
you know that like that's gonna go.
Yeah, has to. Because it has to go through that open circle, like go through it. Yeah. Yep. It'll drive me nuts. Like there will be students that struggle with this stuff, and that's fine. That's not what drives me nuts. What drives me nuts is like when there's like non-logical things that happen. Like to your point there, like I'll have students that'll do this. They'll find like where the hole is. They'll draw a graph and they'll say, oh, here's the hole. And then they'll draw their graph and it'll go like this. Well, that's impossible. Like your graph has to go through that open circle. There's things like that that just don't make any sense. Or I'll have students that'll be like, there is no x-intercept. And then they'll draw their graph and it'll be like literally going through the x-axis. Like you just said there's no x-intercept, but your graph is crossing the x-axis. Like those things just don't make sense. So those are when like, it's like, what is happening? But were you gonna say something, Audrey?
No,
All right, last one. Let's factor and cancel, shall we? We shall. Okay. That's my student voice. That's what I imagine all of you sound like. So I'm going to factor this, x minus 2, x plus 1. You can see how important it is to get your signs correct. Like if you would flip those signs, like everything would be wrong because nothing cancels. But if you flipped your signs on top there, then you would find like a hole. You would have no vertical asymptote. Like everything would be wrong. So just pay attention to your signs. All right, let's find our stuff. Marwa, there are 6 things to choose from now. Pick any one of those 6. X equals 1 is our vertical asymptote. Booyah. She's on fire. This girl is on fire. No, no. Can't make it big. That's a shame. Next. Alicia, there are 5 other things to choose from. What would you like to find?
The horizontal asymptote is none.
There isn't one. Very good. So this is the first time. All the other ones, there was a horizontal asymptote. But this one, the top degree is bigger than the bottom degree. So there is not a horizontal asymptote. On this one, the top degree is 1 bigger than the bottom. So there's going to be a slant asymptote. We'll talk about, that's going to be the last thing I talk about. Okay, so we'll talk about how we find and what it means for the slant asymptote here after we find the other stuff. A few more things to find. The y-intercept. Ms. Downs, what would the y-intercept be? If you plug 0 in for all those x's, what are you left with? So what are you left with on top? If you plug 0 in for these x's, what's left on top? -2. And what's left on bottom? So what's -2 over -1? 2. So 2 is our y-intercept. Basically, the y-intercept, guys, is whatever your constants are. Those are going to be the things that are left. So in this case, 0, 2. All right, all right. Are there any holes on this one? Anything cancel? No. Get out of here. Holes? None. X-intercepts are whatever make the top of your fraction 0 of the simplified fraction. Well, nothing canceled. So we actually have 2 x-intercepts on this problem. You are allowed to have multiple vertical asymptotes. You're allowed to have multiple x-intercepts. You can only ever have 1 y-intercept, though, at most. Why can't you have more than 1 y-intercept? But you can have more than 1 x-intercept. Why is that allowed? Yeah. Yeah, you can't have more than 1 y-intercept because if you did, then it wouldn't be a function. You would basically be saying when x is 0, there's 2 different y values. You'd have 1 input going to 2 different outputs. Can't have that. So do you have to know that? No. I just like talking about math. I could talk about math for days. So the x-intercepts are at 2, 0 and -1, 0. Math, 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 math. God, these are lame. All right. The slant asymptote, the very last thing, the one thing we haven't really talked a lot about. So first of all, you're going to have a slant asymptote when the top degree is 1 bigger than the bottom degree, as in this case. What that means is this, like on all the other problems with horizontal asymptotes, your graph is always leveled out horizontally eventually. With a slant asymptote, that means, well, first of all, you're never going to have a horizontal and a slant on the same problem. That's impossible because if the top degree is bigger, there is no horizontal asymptote. That'll never happen. But what it means for a slant asymptote is you're going to have like a slanted line, a diagonal line, that your graph, instead of like leveling out horizontally, it's going to be approaching that slanted line as x gets really big. Like it's going to model that line instead of going horizontal. It's our job to find the equation of that line, that slant asymptote. Okay. So when we're finding the slant asymptote, we are finding the equation of a line, like y equals mx plus b, like y equals 3x minus 1. We're finding an equation of a line. The way we find that equation, we do long division, polynomial division. Yes, remember how to do it? Some of you may, some of you more likely not. And the reason you might remember like doing it, but you don't remember actually doing it is because in that chapter, we did a lot more synthetic division than long division. So that's why you might not remember long division. So I'm going to refresh your memories on long division. So we are going to set up our division. My son actually started yesterday long division with his like just numbers. He said he does not like it.
Different now.
Well, they started with a different strategy, which when I first read the paper they sent home, I was like, what is this garbage? I didn't like it. But then he was doing problems and like explaining it to me. And I was like, oh, I like that a lot better than like the actual long division. It was nice. And now he's doing the actual long division. And to me, it's like, oh, this is stupid. I mean, when was the last time you guys did long division with numbers? Exactly. So, oh, that. Well, I'm glad you remembered how to do it then, if you got it right. In here? Why didn't you ask for a calculator? Think about calculators. Okay. All right. So we are going to divide. All right. So to refresh your memories on this process, when we divide, we just do the first term divided by the first term. When we do the division step, we just do the first term here, x squared, divided by the first term out here, x. X squared divided by x is x. So we do first term divided by first term. Then we take that and we multiply it or distribute it back through our divisor. I think that's called divisor, not the divisor. Dividend, divisor, quotient. Is that right? Okay. It's funny how I can do like all this upper level math and I just forget all the other stuff.
I don't. We have that on test website.
So now we are going to subtract straight down. When we did this, I said, guys, don't subtract, flip all the signs and then add. Like you're just subtracting the opposite, and subtraction causes issues. So I would make these opposite signs and then add straight down. So the x squareds and the x's cancel, and we just bring down the -2. Now I'm going to be honest, and I'm going to apologize in advance. I gave probably the worst example of what would typically happen with slant asymptotes on this problem. I'll explain why. Okay, I didn't intend it to happen. But when we're coming up with the equation of the slant asymptote, all we really care about is the x term and the constant, like y equals mx plus b. We want the like 2x plus 4, 3x minus 1. Like that's all we care about. When we did long division, we got into like the remainder and stuff. Like this would be the remainder. The nice thing is for slant asymptotes, the remainder is irrelevant. We don't even care about the remainder. All we care about is the x term we get here and whatever constant we would get here. The reason this is a bad example is we didn't end up getting a constant on this problem. I'm going to show you a different long division one where that would happen to kind of drive the point home. But my point is this: the slant asymptote is y equals, and it's whatever you get up here as your quotient, your line. So like, for instance, let's say there was like a +1 right here. The slant asymptote would be y equals x plus 1. There is no constant, so it's just y equals x. I'll try to make that make more sense here in a second. So I'm going to graph, instead of graphing a horizontal line, I'm going to graph the line y equals x. That's my slant asymptote. So the line y equals x, you guys just had to do that on your test, but that's like the y-intercept is 0 and the slope is 1. It's this diagonal line here, goes to the origin. So when we decide where our branches go, it's the same exact thought process as if that was a horizontal asymptote. We treat the slants and the horizontals like the same. What I mean is this: to the right of that vertical asymptote, over here, to the right of x equals 1, the branch is either going to be up in this region, like this. So instead of going horizontal, it's just going to like curve and go at that angle there. Or it's going to be down here and look like this. Look at my pen. It's going to look like this. Since that point is here in this area, I know that branch is going to be down here and approach that slanted line instead of going horizontal. I didn't approach it very well, did I? That was poopy. Didn't mean to do that. I don't want to draw over it, so it'll make it look worse. But it should get closer to that dotted line. Same thing on the left side of that vertical asymptote. Over on the left side, I know the branch is either going to be up in this region or down in this little skinny region down here. And since I already have points up there, I know it's up here. I'm gonna make this one better. Yeah, snuggle it up. There we go. That's better. Not perfect, but better. So I do want to do, I want to show you guys one that also could happen. I didn't give a very good example with that. So you don't need to write this if you don't want to, but I want to show you guys this. Let's say that you were looking for a slant asymptote and you had to do long division here with this example instead, okay? So first thing I would do is x squared divided by x is, oh, wait, it's another, just a bad example too. Here. There. Oh, I can't promise that. Oh, it did work. I just wanted to show you one where you end up with a constant, because that could, both could happen. I'm just saying, I'm not saying this one was any more difficult. I'm just saying, I wish I would have started one where there was an x term and a constant, and then done maybe one like that. I wish I would have flipped. Yeah. So on this one, let's say I go through and I'm like, okay, x squared divided by x is x. And then I distribute it back through. So x squared plus x. And then I subtract. So notice on this one, the x terms don't cancel. Like on this one, they did. That's what kind of caused, I don't want to say the issue, but that's why I wasn't too pleased with having this be the first example. So let's say they don't cancel. So I subtract and then I bring down the plus one. Well, if this is the case, I can do division one more time. On the last problem, I couldn't do division anymore. Like I was done because this degree right here, there was no x's. It was less than this x here. I couldn't actually do the division anymore. Here, I can do the division one more time. I can do x divided by x. That's 1. But the nice thing is, once you find the x term and the constant, you're free to stop. That's all you care about. Like whatever the remainder would be is erroneous. It's irrelevant anyway. Like our slant asymptote would be y equals x plus 1. There's no point to keep going once you find the constant, is my point. All right. Thursday, we'll practice more. And then Monday, we will have our quiz. Wednesday, so you'll have a quiz and learn about circles again. Wednesday will be parabolas for e-learning. That's not ideal, but it's what I had to do. And then Friday will be a review. Then we have our tests the last week before spring break. The nice thing is you guys won't have anything else the rest of that week. So you have kind of an advantage because you'll take your test that Tuesday. Is it that Tuesday or Monday? Tuesday? Is it? No, it's Tuesday. Yeah, it's Tuesday. So you guys will have your test that day, but then you'll basically be off for my class. You'll have 3 weeks away from us. You guys at home will have your test till Thursday, but you won't have e-learning that week either. Oh, you wouldn't anyway, but. All right, you guys at home, you are free to go. There's some practice to graph these. And peace out, homies. All right. Good day. Good day.
Wait, for the third one.